Welcome back to the Contact Manager project. So this would be section 2 of part 1. We're working with the name object that we created in the previous lesson. And just a quick review, the name object has two instance variables, first and last, and it's one of the design principles of this class that first and last should never have null values. A name should always have something stored in it. So in the default constructor, we set first and last to be empty strings. An empty string is a string with a length 0, and you create it by putting quote quote when you assign the value. Then in the overloaded constructor, where we take two strings as parameters, we first check to make sure that the parameter strings are not null. If they're not null, we go ahead and use those, but if they are null, we again assign an empty string, thereby guaranteeing that first and last will have some value stored in them. Then we wrote some getter methods that just simply returned first and last. And then we wrote a two-string method that combines first, last with a space between them, and a getLastNameFirst getter method that returns last comma first. And then finally we wrote an equals method. The equals method is inherited from the object class, so we are overriding the inherited equals method with our own equals method. Now, the inherited equals method says that two objects are equal if they have the same hash code, which means they are in fact the same object. But we're going to redefine that for the name object and say that two names are equal if the first names are the same and the last names are the same. So first what we do is we use the keyword instance of to check to make sure that this other object that we're being compared to is in fact a name object. If it's not a name object, then we use the inherited version of the equals method by calling super.equals, and we just pass this up the chain. In other words, we're only going to respond if the thing we're being compared to is also a name object. So how does that work? Well, first we check, since we know that we are a name, we can cast our other object so that it becomes a name object. And then we can check to see if the first name is equal to the last name, is equal to the same first name of the other name, and that the last names are the same as well. If both are matched, then we're going to return true, otherwise we return false. And then finally we have some setter methods, and in our setter methods, again, to guarantee that there are never null values for first or last, when somebody tries to set the first name, we make sure that they didn't pass us a null value, and we only set it if it's not null. Okay, so let's start writing some code that uses the name package. And we're going to have two different versions of this, one for this lesson and one for the next lesson. So we're going to call this name runner arrays, or array. And then public static void main. And what is our class going to do? Well, we're going to, so the name runner array class is going to instantiate names into an array of name objects. And that's basically it. And this will serve as a review of how you put objects into an array. Okay. March 19th, 2015, and we are ready to go. Okay, oh, there's one other thing that this is going to do. I'm sorry, we're also going to, and we're going to introduce a new form of for loop, colloquially, I probably didn't spell that way, commonly known as a for each loop. Okay, so How are we going to do that? Well, we're going to start by declaring an array. So what is our array going to look like? We're making an array of names, so that must be the type, and it's an array, so we add the square brackets. Then we have to give it a name. Well, it's an array of name, so we'll call it names. And then we have to use the keyword new to create our array and say how many names we want in the array. We're going to go with 5. And then we need to start populating the array. So when I want to instantiate an object, I declare the object using its type and then a name. I'm going to call my name object a name. And then I use the keyword new, and then I call the constructor, which has the same name as the object, but a constructor is a method, so it's going to have parentheses after it, and then a semicolon. Now, this is very confusing often because it seems that this and this are the same thing. This is the type, which is the class of the object. This is a method, and it's the constructor method that is being called. And that's why it seems to be redundant that we're saying the same thing twice. But it's really important to understand we're not. Okay, so I have a new name. What's stored in that name, of course, is just an empty string. And I want to change that. So I'm going to say a name dot set first, and I'll put my name in there. But I also want to set the last name. So I'm going to call the method set last and set it equal to that. Okay, so I've got a name object, but is my name object in the array? And it, of course, isn't. The first element in the array has an index of 0, so I'm going to set that equal to the name I just created. Now recall just a moment ago, I pointed out that this seems redundant because I have name twice, and that could be very confusing. But you're about to see the difference here. If I declared a variable int x and gave it the value 5, on the next line I could say x equals 10, changing its value. Well, I could do the exact same thing here. This would be the equivalent of this line of code. I've declared x, or in this case, name. And then on the next line, I'm going to assign it a new value. I'm going to say a name equals new name, and this time I'm going to call the overloaded constructor. There we go. Okay, so now I've got another name in my array. And then, oh no, I don't have it in my array. I have a new name stored as a name, and now I need to put it in my array. Names1 equals a name. Okay, so what's next? Well, let's add some more names. Is there a shorter, faster way to put a name in my array? Well, let's say I wanted to put a new name in, but it's okay with me if it's blank. So I could say names2 equals new name using the default constructor. And then, of course, I could change that name by directly addressing it from the array and do set last to somebody else's name. But what is the first name still going to be for this name? It will still be an empty string. Okay, and what am I going to do next? I still need a few more names, so I'm going to say names3 equals new name. And let's test our constructor here. I'm going to give it a first name and then no last name. But what should happen is my name should end up not with null stored there, but of course with an empty string. And then finally, I'll do my fourth name equals a new name, and we'll give it a proper name. There we go. So what do I want to do with this array now that I've created it? Well, typically we want to output the values of the array. So we're going to output the values using a traditional loop. Output the values using a traditional for loop. So I'm going to say for int I equals 0, I is less than the length of the array, I plus plus, I becomes my iterator. Then I'm going to do a system out where I'm going to print names plus my index equals, and then the value of the array. Now, notice that in this case, I'm not calling a method. I could have done names dot get last name first, or I could have done names dot toString, or get last if I just wanted the last name. But what do I actually want? I want my, let's see if I do toString, the name in first space last format. Well, do I need to say toString? Since this object is being combined with a string, it will be expanded into a string automatically using the toString method. So let's go ahead and run our code here and see what we get. That's interesting. There we go. So, what did we get? Each of the names, notice that there's a space there because we did first space last, but we didn't get a null there, so our code was working properly. Everything seems to be working. Okay, so that is a traditional for loop. Let's see the same code written using the for each loop. So output the values using a for each loop. Okay, how does a for each loop work? Well, in a for each loop, I'm going to move this up. In a for each loop, what you do is you get to iterate over each value in the loop by storing the current value in a variable that you create. So let's take and add one more step here, an intermediate step in my loop over here. Because I'm using names I here, I could do something like this. I could say name equals names I, right? And then here I could print name. All I'm doing here is I'm taking the current value stored in the array, storing it into a temporary variable, and then outputting that instead. Well, that's essentially what the for each loop does. So how does it work? We say for, but we're not going to have an iterator variable that is an integer. Instead, our iterator variable is actually going to be a name object. And what value is it going to get? It's going to get each value stored in names. Now, I know this looks confusing. Why do I have a type here and then a variable? This is the type of the iterator variable. This is the iterator variable itself. And then this is the collection from which this variable is going to take its value, and it's going to get each value in this list in order, starting with the first until it gets to the last. And then I could just do a system.out.println of the name. Let's look at the difference in the code. Now, you might notice one very big difference. Here, I output the index along with the names. Here, I haven't output the index. Why not? Well, how was I printing the index? I was printing it using the index iterator variable, but there is no index iterator variable that is an integer here to tell me which name I'm on. So the for each loop is, well, if you look at the two, it's somewhat shorter, it's more compact, but it is also somewhat more limited. It's used only in circumstances where you want to go through every name in the list, all the names, in order, one at a time, and you don't need to know where it falls in the list, and you don't really need to know anything else about the name or about the number. Okay? So it's not always the most convenient. But in the next section, when we introduce our next big concept, which is something called the list interface and array list class, you're going to see that this for each loop can sometimes be much more convenient to use. And it is part of the AP subset, so you do need to know about it and how it works. You don't need to be able to write code using it, but you have to at least be able to read it when it's used.